Hello, I'm Elizabeth Howell from SkyNews. I'm with NASA astrophysicist Padi Boyd, and today we're going to be speaking about the Hubble Space Telescope's observation of an interstellar comet. So what does it mean when we say a comet is interstellar?
So what it means is that it is not bound to our solar system. So the Earth and all the planets in our solar system, as well as all the asteroids and the comets that we've known about up until this point in time, have all been gravitationally bound to our sun. It's most of the mass in our solar system, and planets, asteroids, and comets in our solar system orbit around the sun in closed orbits. They come close, and they go back out, and comets in particular on very elliptical orbits. They come close to the sun, the ices in there evaporate, sublimate off, and make these beautiful tails that give you that cometary look. Now this comet, when we look at its orbit, it is on an unbound orbit, a hyperbolic orbit, so it is actually zooming through our solar system. It's made its close approach to the sun just this week, and that's it for this comet. It is now going to zoom right out of the solar system, never to be observed again. So telescopes and observatories and scientists on the ground and in space are taking this rare opportunity to observe a comet from another solar system and compare it to those that we know so well in our own solar system.
And in what ways are Hubble's views of the comet unique from other telescopes?
So Hubble is up in space. It is above the atmosphere. It has been up in space for 30 years, and it has a variety of instruments on it that can observe at wavelengths that are not visible to the human eye. So it can go further into the red or the infrared. It can also go into the ultraviolet. And so Hubble is also has exquisite vision, so it can very precisely record the position and the brightness of this comet. And so we're taking the opportunity to observe the comet with Hubble.
And Hubble has been looking at the heart of the comet since October. What has it seen so far?
So it's looking at the comet as it zooms into our solar system. It sees a central region that is not very bright. We're seeing those gases, those ices that are starting to evaporate off and form the fuzzy-looking coma and the tail, and we're comparing it to comets in our own solar system. And right now I think one of the most interesting aspects that we're seeing about this comet is that it's kind of a garden variety comet. It looks very much like the comets in our own solar system, and that's so interesting because this is really the first time that we've been able to observe a comet from outside of our solar system. And so one of the first things you would ask is this like the comets in our own solar system or not? And if it's similar, is that implying that the process of solar system formation that we are learning so much about in our own solar system is actually general, that it's the same process of star and planet formation around other stars, and this comet is indicating that that is in fact the case.
That's really interesting. And how about the chemical composition? Is that any same, or is it different from solar system comets that Hubble has looked at?
So we have not looked at those observations with Hubble as yet. There are many telescopes in space and on the ground that are looking at the comet. The images that we're sharing today from Hubble are actually images, so they're not spectra, but Hubble does have the instrumentation on board to take spectra of objects such as comets and anything else in the local galaxy or the universe, galaxies beyond, and so do the ground-based telescopes. So that is one of the questions that astronomers are very interested in. We will be taking data to look at the chemical composition of this comet and compare it to other comets.
Great. And then what about the size of the nucleus? Have you been able to image that, and is it important to astronomers?
So you can put limits on the size of the nucleus of the comet, and that is interesting. I mean, everything about comets is interesting to us. They are certainly the building blocks. They're the leftover remnants of solar system formation, and they freeze into them almost like fossil records of how the solar system began and what it was made of and what the process was. So this is really our first chance to look up close at a comet from another solar system and to determine the same types of things. So comets come in a variety of sizes, and this comet actually looks to be on the small side compared to comets in our solar system, but not really out of family small. It's just a smaller comet. And it also, if you look at the what we think it's probably made of and how that tail is evolving with time, it looks pretty consistent with this being the first time that the comet has come close to an object like the sun that is evaporating off all of that material. So we're really kind of getting a once-in-a-lifetime view of this comet.
And how has the comet's activity changed since it got closer to the sun?
So this comet does not actually get as close to the sun as many of the solar system comets do. It has actually just come in for its closest approach just in the last few days. But even so, it was further from the sun than Mars. So that's almost twice the distance that Earth is from the sun, and the Earth is far from the sun. It's 93 million miles away. This comet was about twice that far, even at its closest approach. But what we've seen with Hubble is that the comet has evolved in a very typical fashion, similar to other comets in our solar system. Each comet tells its own unique story about where it came from and where it's going. Some comets get very active. Some of them are extremely variable as they get close to close to the sun. This one is actually evolving on a very typical path for a comet. It's getting brighter and bigger as those materials evaporate off the surface and start to reflect sunlight. So actually the fact that we're not seeing anything super different from the comets in our solar system is interesting in and of itself.
And then what's coming next for Hubble observations of the comet?
So Hubble will take a few more observations as the comet leaves our area of the solar system. So it is just coming in one time. It's just passed close to the sun, and it will go out of our solar system on what we call a hyperbolic trajectory. It's unbound. So Hubble will be watching it a little bit longer as it goes further away. And there's lots of things to look at in those observations, including the fact that we'd really like to understand its orbit better. And the more data that we get that we can compare as it's coming close to the sun and going out, the better we'll be able to pinpoint that orbit.
All right, thank you very much for your time. That was Padi Boyd, an NASA astrophysicist who was speaking about the Hubble Space Telescope's observations of an interstellar comet.
My pleasure. Thank you.